In continuation of DP1, DP2 consists of process control and instrumentation, process integration, design of major equipment, plant and safety layout, and economic analysis. My name is Melanie EASTERMON, and I will be presenting on the first topic, which is process control and instrumentation diagram. So in this topic, there are three objectives, which are safety, quality, and profit. So for safety, the safety of plant, personnel, and community is the priority of any operation. And next, the quality in blending and batching operation. Control system maintain the proper ratio of ingredients to deliver consistent product. And when both safety and quality are met, there comes the profit. Profit will be maximized to the closer to the process in the operated to the constraint. So there are three process control systems that we use, which are feed-forward control, feedback control, and cascade control. The feed-forward control will provide the information on the past activity and performance, whereas the feedback control will provide the future activity and performance. And for the cascade, it will be using two controllers, where the first controller is used to set that point, and the other one usually used for feedback controller. So in pump and compressor, they have the same objective, which is to monitor the pressure in the outlet stream. And for the heat exchange, the process control is used to achieve the temperature that is needed for the outlet product stream. And for hydroformylation reactor, the upper part is to control the pressure in the reactor, and the lower part is to control the temperature in the reactor. And for the hydrogenation reactor, it has the same function, which is to maintain the temperature and pressure in the reactor. For vessel separator, at the upper part is to maintain the pressure at the top outlet of the process stream, and the lower part to maintain the liquid level at the bottom of the vessel. And lastly, for the distillation column, it has three objectives, which are to control the temperature at the top of the column and the composition discharger, and to control the flow of the reflux, and lastly to control the level in the column from flooding or from having a low flow rate. So this is our process and instrumentation diagram. Next, I will pass this presentation to Miss LIYANA. Thank you.
Assalamualaikum. My name is Siti LIYANA binti Muhammad MOKHALDIN. The topic of my presentation is process integration. The objective of process integration is to reduce utility consumption for a better design and to reduce utility costs. The data extracted are obtained from the energy balance calculation from Design Project 1. The selected minimum temperature difference is 10 degrees Celsius. In the system, there are 4 hot streams and 4 cold streams. The data extracted obtained will be inserted into the problem table algorithm. The purpose of heat cascade diagram is to locate the hot and cold pinch temperature as well the minimum requirement of hot and cold utility. From the calculation, the hot and cold pinch temperature is 57.4 degrees Celsius and 47.4 degrees Celsius respectively. As for the minimum requirement of hot and cold utility is 18 million kilowatt and 690,000 kilowatt. Try and error calculation is made until we obtain minimum requirement for hot and cold utility, same as in the heat cascade diagram. Based on the first diagram, the heat exchanger available is 6, but after it is optimized, the available heat exchanger is 5. Other than that, the heating requirement of hot and cold utility increase after the optimization. The capital cost will increase when number of heat exchanger decrease and heat loss increase. Thus, we conclude that it is best not to proceed with process integration as we obtain almost 0% energy saving.
Next, the equipment design of heat exchanger. A heat exchanger works when two fluids of different temperature inlet, which is known as hot and cold fluid. The hot will be cooled by the cold fluid via heat transfer or vice versa. So, in the first diagram is the physical properties of the shell side and tube side. In the shell side is the gas mixture which contain carbon dioxide, hydrogen and ethylene, whereas the tube side is the cooling water. In the second diagram is the summary of mechanical design of exchanger 100. The material of construction that we are using is carbon steel. The design pressure of this heat exchanger is 6.6 bar, and the temperature design for shell side is 205 degrees Celsius and tube side is 44 degrees Celsius. The head type we are using is ellipsoidal head, and the flanges type is welding neck. The baffle type is segmental with 25% of baffle cut, and the number of baffle is 10. In diagram 3, it is the summary of chemical design of exchanger 100. The heat load we are using here is 3737 kilowatt, and the number of tube is 288 tubes. The pressure drop for the tube side is 76 kilonewton per meter square, and for the shell side, the shell diameter is 0.522 meter square, and the pressure drop is 2391 kilonewton per meter square. And this is the drawing of the heat exchanger.
Assalamualaikum, my name is Muhammad Haziq. Now we will proceed to the reactor design for hydroformylation reactor. For my reactor design, I choose multi-tubular fixed bed reactor because it is mainly for gas phase catalytic reaction. And in this process, it involves hydrogen, carbon monoxide and ethylene which entering the reactor in a gas phase to produce propanaldehyde also in a gas phase. The order of the reaction is a third order since it is elementary and it follows the stoichiometric reaction. And the assumption made in the preliminary reactor is the reaction is in a steady state. The start of the reaction is neglected and the reaction is exothermic, while the volume of the reactor is determined by using the area under the graph with a trapezoidal rule. In this figure shows AutoCAD drawing for this preliminary design reactor. The vessel of the reactor is vertical and in a cylindrical shape, and the material chosen for vessel, tube and support is a carbon steel because it is affordable and it can withstand the operating temperature inside the reactor. And based on the calculation, the volume of the reactor is 71.93 meter cube with height 11.36 meter and diameter 2.84 meter respectively. The cooling system was also calculated since the reaction is exothermic with a mass flow of coolant at 163.01 kg per second. And the reactor also consists of insulator which is mineral wool to absorb excessive heat and to prevent reactor from overheating. The wall thickness and the skirt thickness were calculated to be 8 mm and 18 mm, which is very sufficient to withstand the dead weight loads and bending moment imposed by the vessel respectively.
Next, I will present on the design of separator V101. Separator V101 is used to separate liquid and vapor phase. The mechanical design focus on the elements such as stress analysis, material of construction, and operating data. Right here is the overall design of separator V101. The height and diameter of the vessel is 1.7 meter and 0.7 meter respectively, made from carbon steel. The dome head is ellipsoidal and flare skirt as support. The mister pad is added to remove the mist from gas vents.
Assalamualaikum and good day to all panels. My name is ROZWANI binti KAMSANI, and for design equipment, I will present on packed bed reactor. I chose this reactor because of its suitability for the process. It involves multi-phase reaction where liquid propanol will react with hydrogen gas with the presence of solid nickel as a catalyst. Another reason why I chose this reactor is because multi-tube reactor will give high efficiency in heat transfer. After doing some calculation, the volume of this reactor is 73.25 meter cube with a diameter of 2.858 meter and the length is 11.432 meter. The volume of catalyst is 22.23 meter cube and the operating temperature and pressure is 538.35 Kelvin and 320 kPa respectively. The material for the reactor is carbon steel because it is durable, safe to handle, and also very cost effective. This is my AutoCAD drawing, and the dimensions shown are based on the calculation that I did before. As you can see in the drawing, the top view of the reactor shows the diameter of the vessel. At section A, you can see the inside view of the vessel that consists of 729 tubes. Section B, you can see the baffle of this reactor, which it has 18 baffle. The head of reactor is ellipsoidal with the thickness of 4.733 mm.
Assalamualaikum and good morning. My name is NURSAFIKA and I will present on the equipment design of distillation column. The purpose of distillation column is to separate the liquid propanol, which consists of propanol, propanyl dipropyl ether and water. Propanol was chosen as the light key while the dipropyl ether as the heavy key. So for the chemical design, we need to calculate the dew and bubble point temperature of the composition and also the diameter of column, height of the column, the number of stages and the efficiency of the column. For the mechanical design, we need to identify whether the temperature and pressure is suitable for this operation. Also, we need to identify the type of skirt that can be used in this column. Next, we go to the AutoCAD drawing of distillation column. There is the details of designation. And we use ellipsoidal head at the top of the column, and there are 28 stages of this column, which the feed stream is at stage 12 from the top of the column. The support design, we choose the skirt support with a height of 2 meter and 9 mm of thickness. That's all from the designation of distillation column.
Okay, now we will proceed to the plant safety and layout. Safety is very important in all working sector, especially it related to a chemical industry since it deals with high temperature and high pressure, and it need to be monitored regularly to ensure the safety of the process. Hazard identification, risk assessment and risk control hierarchy is important to ensure that any potential risk to safety, health, environment and business aspects of any operation is minimized. Identifying hazard and assessing risk are important to reduce the probability of accident, and it should be seen as a bigger issue. Okay, in this table shows hierarchy form for our plant production. The work activity in handling of a flammable gas, ethane, hydrogen and carbon monoxide, is identified as hazard due to its possibility to cause fire and explosion if leakage occur. Then the effect of hazard, it will cause respiratory problem. And in order to control the existing risk, we provided the containment device to avoid the fire and explosion, and to ensure that our workers to wear respiratory protection. The main objective of HAZOP is to identify, analyze or quantify the hazard process. HAZOP study is to make the assumption that hazard or operating problem can arise when there is a deviation from the design or operating intention. Okay, this table shows one of the Haziq study for the separation vessel. When the flow is deviate from normal, such as high flow, the possibility is because of the failure of a control valve and incorrect of a flow meter reading. Thus, it will not achieve a desired separation and may rupture the pressure vessel. And to prevent this deviation, the flow valve control need to install and daily check of a control valve.
Next, I will continue this presentation with plant layout. Our production plant is located at Kerteh, Terengganu, and to determine the plant layout, there are a few factors that must be considered, such as the geographical constraint of the site, the emergency route for on-site personnel, the spaces to do maintenance and operation of the plant, and the location and spaces to store hazardous and flammable storage. We did some research on the prevailing wind at Kerteh, Terengganu, and we did found that the wind are most come from south. Based on Department of Environment, the classification of industries and potentially polluting hazardous activities is determined that our 1-propanol production is under category 2, as it is described as the heavy type of industries that have high potential and high risk of fire and explosion. This is because of the raw material that we use, which is hydrogen gas that is known as flammable gases. The guideline from Department of Environment also provide 2 types of buffer zone, named primary buffer zone and secondary buffer zone. Our plant is primary buffer zone, and the minimum distance of buffer area is 350 meters from the residential area. In the slide, you can see the 2D drawing of the plant layout, and the location of each building or area is determined by following the factor that I mentioned before. Here is my 3D drawing, and at the drawing you can see we have 2 emergency exit, which is located at the back and the right side of the plant. We also have monitoring tower to monitor all the activities or any situation that may happen in the plant. For emergency response plan, it is done to guide workers for any emergency situation either caused by production or natural disaster. The objective of this plan is to provide guidelines for action and managing any emergency event, to ensure the safety of workers and public, to reduce property and business losses, and also to ensure staff have skills and ability to act rationally and effectively during the emergency event. One of the possible accidents that may occur in our plant is the hydrogen leakage, and if this happens, fire or explosion may occur. So, to handle this kind of emergency situation, we did have some on-site and off-site plan. For on-site plan, internal safety surveys and inspection will be done periodically by Department Safety Committee. And we also have other inspection such as pressure testing, safety valve testing, fire system inspection that will be done by the fire department team. We also have planned the action during emergency, such as how to control the emergency, evacuation and transportation, and also safe shutdown. For post-emergency activities, we plan to have rehabilitation session to the one who need it. Next, for off-site plan, the communication will be handled by telephone operator, and they will ensure all telephone lines are ready at any time during the emergency. And the other were chemical information, which we will provide SDS for every chemical that involved in our production plant. And next, we also have humanitarian arrangement. So that's all from me. With that, I thank you.
Last but not least, we go to the economic analysis. This is important component in evaluating the profitability of the project plan. The fixed capital investment of the plant, which include the estimation cost, module cost, equipment cost, raw material cost, and other costs, has been calculated. These are the assumptions that we made for the profitability analysis. which the plan life is 10 years with 12 years of construction, and the currency exchange rate is 1 USD equal to 4 ringgit 37 from the Bank Negara Malaysia, and the purchase cost of the equipment record from January 2020 for the average 2019 equal to 603.9. So to see the efficiency of our plan, we need to do the profitability analysis, which measure the amount of profit earned during the project and it used to assess the profitability of the project involving both capital expenditure and yearly operating costs. So this is the summary of our plan, which consists of 2 years of construction period with 10 years plan life, and the internal interest rate is 2.70%, and while the taxation rate is 30%. Our first capital investment is 49.08 million, with the first year contribute 60% and the second year is 40%. In this capital plan, we purchase a new land which is 14.35 million ringgit Malaysia, and we use depreciation method MCFS for 5 years. Next, we go to the cash flow diagram of non-discounted and discounted cash flow. The economic analysis of project assume that any new land purchase are done at year 0, and that once the decision has been made to construct a plant, then a construction phase is begin. And at the end of the year of plant life, the working capital and land is recovered, which is at year 12, and the salvage is added in revenue. Next, we go to the non-discounted diagram. As we can see from the diagram, the payback period is 3.53 years, with the cash cumulative present is 92.01 million ringgit Malaysia, with the rate of return of investment is 34%. For the discounted cash flow diagram, we can see that the payback period is 3.5. Difference with discounted is only 0.02 years, and it is less than 5 years. And the net present value is 93.03 million ringgit Malaysia, with the discounted cash flow rate of return is 15.2%. It can be concluded that from the broad diagram, the payback period is less than or 5 years, and it required 3 years to recover back the fixed capital investment. Thus, this plan has future value because it is economically feasible and it will contribute promising return of investment.